say, I will, that's probably one of the things I'll try to do this weekend. If they'll leave me alone, TIF grab.
Yeah.
That's one thing I just told Paul. I said, so Friday, I know I'm off Friday, but I'm gonna spend Friday getting this NATEF stuff lined out. I'm gonna have a list Monday of who I need information from and what information I need. Because he's wanting it now, it's like I don't have time to deal with it. So,
Yeah.
Yeah, because I was just talking to Lacey, I says, I know when you get the job sheets done, I says, but I didn't get them all printed off from last class, so I don't know if, because my question to her was, I didn't know if we could go back into the previous classes to print them off, and that's what we were just checking.
Yeah.
Right, so you did figure out how
Yeah.
to do that.
Yeah, we can, because when I first, it didn't highlight that little printer. It was just kind of like
Mhm.
sitting there, and so I'm like clicking it. I'm like, shit, I don't know if this is gonna work.
Yeah.
So eventually it did come up to where it just was taking.
Yeah, so worst comes to worst, I go back and take the end date of the class and change the date to something later, like May 10th, and then pop all back up. And so, and there again, so I'm gonna, when I do the grades for that class, I'm not going to grade any of those. I'll eliminate them from the total points possible.
Okay.
And then do the grade. But we'll carry all those over to this class. And like I say, I wish, I've talked to the people so many times, it's like, nobody knows what they're doing.
Yeah.
At least the people I get to talk to.
Yeah.
But well, let me back up, okay? I haven't, the last time I talked to the lady that's the trainer and also the salesperson, she basically said, okay, you're gonna have to talk to the technical assistance people on this one, and gave me their phone number and all that. Well, I called and got put on hold for like 10 minutes and finally had to do a class or something, so it's not up. And I haven't tried calling back.
Yeah.
So I don't know if they can actually do what I want them to do or not.
Yeah.
But she could not do what I want her
Well, just so you know, we
But
can
she
print
tried.
out, so you don't
to
have
do.
to
She tried, so.
deal with all that crap if you don't want to.
But yeah, if we, one of the things that I'm looking at here is with this update to our NATEF certification, I'm adding in 15 hours per class of MindTap. And so I don't know that the job sheets really need to be on there for that, because those really aren't going to be outside of class. Those will be done in the shop. But the other stuff is all done outside of class. So one of the things that I've got to do is go back and look at time and see how much time people have been spending on these things that we've been assigning, and making sure that we're around the 15-hour mark, at least 15 hours, because if we're not going to meet the standard, because we got to have 1,200 hours total for the new master standard. So
Could that?
it went from 840 to, well, 1,000 on their first update thing, and then they just said, well, that's not enough, we're going to 1,200. So
Could they, with that, would they be able to, like, there were certain classes we were talking about before when I wrote in our evaluations about extending them. Could that help with that if just
well,
put
and
that?
that's what we did. You know, we extended our engine fundamentals class and our manual transmission drivetrain class since you've had them. I mean, we just recently did that. We've got that, like last month, got it through curriculum committee and all
cool.
that. So that's done now.
Right, awesome.
So that's, yeah, that's adding in those hours, which brings us to actual contact hours of the classes that are required for the associate degree to 960 hours. And then 15 hours of MindTap or e-deliveries, what they call, we're using MindTap for that. E-delivery stuff, if we can do 15 hours for each of those 13 classes, keep in mind 3 of those are 6 credit hours, so that would be 30 hours of MindTap. That puts us at exactly 1,200, because that's 240 hours of MindTap. So Now, my other question to the guys that did the inspection is gonna be, when you look at the Mind Tap and the time that you spend on Mind Tap, it doesn't include the time you spend looking up the answers for those quiz questions,
Right.
right? That is also my thoughts. I mean, it's not in the contact hours because you're doing that away from here. So I just don't know how they categorize that, but we should have no problem at all, I think, of being at 1,200 hours. I backed up a slide because you were gone when we talked about this one. So our knock sensors pick up vibration, right? So one of our tests is we can take our scan tool and look at our knock sensor outputs, signals. Some of them will say knock sensor, it'll be a counter. So it counts up every time it hears a vibration. Some of them will show it in knock retard, how many degrees of retarded or timing it's retarded. And so you can do that with I like to use a smaller hammer than that, so I'm not going to break something. But basically, you're going to go and tap on the exhaust manifold and watch the scan tool. You can also take your timing light, if it's got timing marks on the balancer, and watch the timing tab and tap on it and watch it slow the timing down. And so we'll do that out there. It's pretty cool. It's a good, quick, easy way to check, see if the knock sensor circuit. I mean, you do that. If it slows the timing down, you know the knock sensor's good, the harness is good, the computer's actually functioning all at once, right? So it's a good quick test. Okay, EGR systems. We've had EGR since the late 60s. It's designed to reduce oxidized nitrogen. It does it by inducing already burned exhaust back into the intake manifold, going into the cylinders, to basically take up some space with inert gas that won't produce heat when we burn the fuel. Okay? It all mixes in with the air-fuel mixture. Okay? But it's basically reducing the volume of gasoline and air in the cylinder. Okay? But we're still pressurizing the cylinder up to our same pressure, right? Okay, so we still get the BTU content out of the fuel, and we keep that burn temperature below 2,500 degrees, because that's the point where we start producing oxide.
Excuse me.
And so, like I said, this has been around a long time. This is one of the items that the hot rodders always take off. You know, you get in JEGS or one of those catalogs and you can find EGR block-off plates for everything out there. Okay. Our EGR valves operate off of vacuum. And so what happens to our vacuum at wide open throttle? Goes away, right? Intake vacuum goes away. All of our EGR valves are completely closed at wide open throttle. It does not hurt performance when people block it off. Okay. When they block off the EGR valve in their mid-range driving, when the EGR valve is normally functioning, now their spark timing's too fast and their ignition's pre-igniting, and they have to slow their timing down to keep that from happening, and that hurts their performance. So they should have left their EGR valve on there. Yes?
Just in a performance view, wouldn't keeping your EGR health be beneficial? I mean, if there is a way to...
Yeah, what I just said was, if you block it off, you got to slow your timing down. Slow the timing down hurts your power output.
Yeah.
They should have left it on and left their timing where it was.
Yeah, because it's going to recirculate, so it's going to cool.
Right.
So I mean,
So, yeah. So anyway, there's a big misconception out there that EGRs hurt performance.
yeah, but the companies see that, they're like, oh man, everyone has this misconception, so let's sell the crap out of this.
Yeah, I could take a little piece of steel and cut it to where it will bolt on where the EGR valve was, and I can sell that piece of steel and that gasket for like $20. That's a money maker right there.
Oh,
Because you
yeah.
can make that little piece of steel for about $1, and the gasket for like 50 cents. And so, yes, it's a moneymaker for aftermarket.
Just because it says aftermarket doesn't mean it's better.
Right.
I learned that the hard way.
You sell them through performance magazines and people think it's a performance item, right? Anyway.
But I always
It's
tell
very
my
common,
buddy-
very common.
So just because it says Jegs or Summits, it doesn't mean it's fast.
Right. Yeah. So, on that same note, if you're going, if you do eliminate that, then now you've got to run higher octane fuel to keep the same spark advance for the same amount of compression, and so it costs you more money to, if you want performance, it's going to cost you money. Variable cam timing on some vehicles works well enough that they can keep the combustion pressures low enough that we don't get above 2,500 degrees, so they don't even have an EGR valve on them.
Variable cam timing is some cool stuff.
It is.
I got my buddy. My dad has one of those big fancy scan tools. Like I don't remember what it's called. It's the newer one from Snap-on. But
Polaris?
I think so. But like you can actually go in and mess with the variable cam timing, and it has this onboard stuff that you can do it while you're driving it. And I'm like, wow, that's pretty cool. Whoever came up with this idea, and you can set parameters for it. If you're within a certain RPM range, you can like manually adjust it. Like, boop.
Yep.
And I'm like, that's really kind of cool.
Yeah.
Not only from a performance standpoint, but also if you're from within this, RPM range to this RPM range with this much throttle opening, you're in economical mode.
Right.
Versus like all this other stuff, so it sets these parameters for it. It's really, really cool. It was really fun to mess with.
Yeah. So yeah, with variable cam timing, a lot of things have changed for sure, and being able to eliminate some of these. And we used to have a lot of problems with EGR valves. We still have a few problems with EGR valves. Ford had a system where they had a dual pressure feedback sensor that basically was measuring to see if the EGR valve was functioning. And they had lots of failures with those. But basically what they did in the EGR pipe, so a lot of our EGR systems have our EGR valve is mounted on the intake manifold, and then they've got a pipe coming from the exhaust manifold up to the EGR valve. Okay, in this case they're just showing this valve right across this hole, but that's really between the exhaust and the intake. It's really not how they're set up, because that has to get to, some of them are similar, but there's two holes in the manifold where the EGR mounts. Okay, one of them is the exhaust end, the other is the intake, and the passage to the intake run. But on Ford, what they did was in that pipe coming up to the EGR valve, they put a restrictor in that pipe, and then they put two metal hose nipples on it, and there's two rubber hoses that run off of that to this DPFE sensor, and it's measuring the difference in pressure on each side of that restrictor. So they can tell when that EGR valve opens, that pressure drops on the side towards the intake faster than it drops on the side from the exhaust because of the restriction between the two. Okay. Which is kind of really cool how they figured out how to do that. But their sensors were always failing. Lots of them. So that's the most common failure on the Fords, on those systems. And so when you get to dealing with some of those down the road, it's going to come in with an EGR code, and it'll have you to run the test on that DPFE. You can probably guess about 90% of the times that's what it's going to be.
So would your EGR be getting vacuum
brain dead, sorry. I cannot think of the technical term.
Ported vacuum?
Yeah, would it
Because that's
be,
what they get.
be after the,
Throttle plate, yes.
Throttle plate?
Yeah, so it's behind the throttle plate, excuse me, in front of the throttle plate where that port is. Where that throttle plate's sitting in there, of course, I don't know if these have any vacuum ports on them at all.
So it would be getting constant vacuum.
No. Well, okay, let me back up a minute. It depends on the system. Okay. So, one of the things that, well, I wish I had one that had a port there. What you'll see on a lot of throttle plates and vacuum supplies is there'll be a port drilled in this body that lines up just past where that throttle plate is when it's closed. Okay? So it doesn't have intake vacuum on it until you open the throttle enough, and it's vacuum coming from behind the blade pulling up through that hole.
okay.
So it won't be full intake vacuum ever, but it's enough vacuum to operate an EGR valve.
Okay.
Okay? And so it doesn't open until it gets past off idle, I should say. Okay? Now, some of them, let me rephrase that. Pretty much all of them have something controlling that vacuum between the throttle plate or the vacuum supply and the EGR valve. Okay? The early ones used a thermal vacuum switch because we don't want EGR when the engine's cold. It just makes it fall on its face. So they had a thermal vacuum switch threaded into a water passage, and it had a vacuum supply coming from the throttle body to it, and then out of it to the EGR. And when that valve heated up enough, it made vacuum connection between the two. So then it would function anytime we were off idle and still had vacuum. Okay? Wide open throttle, vacuum goes away anyway, right?
Mm-hmm.
So the later styles, when we got into electronics, had an EGR solenoid. Okay. And those typically have manifold vacuum going to the solenoid, and then the line coming off the solenoid to the EGR valve. That way they can turn that solenoid on and off when they want to. Okay. Some of those are still ported vacuum to the EGR solenoid. Probably the step on the very first ones with EGR solenoids is ported vacuum, and some of them today still are that way to the EGR solenoid. When it's a ported vacuum supply, they've just got to turn the solenoid on once the engine warms up enough. And it's kind of the same thing as the old thermal vacuum switch did. The ones that have full vacuum to them, they have to turn that solenoid on and off when they want that EGR moving, right? And so, and they can control how much movement by how much pulse width they put to that solenoid. So there's several different ways that they've done it. You'll notice this one, they're calling that a electronic vacuum regulator valve solenoid, EVRV. Okay. So you're going to see some different names by different manufacturers, and you'll also see this. I have seen on GM trucks, some years they call that EVRV, some years they call that EGR solenoid. It is the same thing, different name, right? It's doing the same thing, just switching the vacuum. Okay. My assumption is when they're using that term EVRV, it's pulse width modulated, so they're controlling. You'll notice that one's hooked, the vacuum line's hooked straight to manifold vacuum, intake vacuum. They're not even showing a throttle plate in this, right? If it was one of the older style that they just turn it on whenever it's warm enough, that intake vacuum line would actually be going to throttle body, and it would be in front of the throttle plate. Okay, so it wouldn't get vacuum until you were off throttle. I've had some EGR failures where the pedal plunger sticks open. Cars won't idle if it's open, as long as the passage is clear. Okay. I have had the occasion of having one come in idling really rough. It was stuck partially open. You cook your vacuum pump, you unplug that. You know, one of the tests on our EGR valve is unplug the vacuum hose off of it put a handheld pump on there and pump it and see if it opens. Now keep in mind, we've got two different types of EGR valves, positive back pressure and negative back pressure. Okay. On a positive back pressure EGR valve, there's a little valve inside that won't let that valve open unless the engine's running. Okay. So to test those, you have to have the engine running, and then you can pump it up and it'll open.
I can see a fault in that.
Right.
Because if it's stuck open and then idle,
So which one is the one that has to be, it's the positive?
Positive means there's got to be back pressure before it will open. Okay. Negative means it will open without the engine running. Okay. So if it's and typically they've got either an N or a P on the cover, and that's all they put, an N or a P. And so you look at that, and so you can hook your vacuum pump up to it. And so I usually do this. The negatives will open while it's running too. So I usually do this while it's running because I'm testing two things. If I put my vacuum pump on there and it pumps up and it holds vacuum, I know the diaphragm's good. But if the engine's running and it pumps up and it kills the car, I know the passage is open too. If I pump it up and it holds vacuum and I know it opened and they didn't kill the car, then I know we've got coking all built up in that passage. And that is kind of common. Some vehicles, the Honda V6s are very bad about it. They have a passage, they have like an EGR plate that sits down on the engine, and that passage is like this long, and it's about the diameter of a straw. And so it just, it doesn't take a lot to close that up. And they're hard to clean out. Take a piece of wire and run up in there. Spray carb cleaner in it, poke it with the wire for an hour or so and get it all out of there. But most of them, the passages are not that big a deal. So and of course our first EGRs were vacuum operated, rubber diaphragm in there. So one of the things that I was talking about ethanol in the fuel and it damaging rubber components. I don't think there was much effect. Obviously, the type of rubber used on the EGR valves, because it's having to handle a lot of heat, is different than the rubber on the canister perf valves and stuff. And so, I really, I've had some that had ruptured diaphragms, but I really don't attribute that to alcohol at all. Probably just normal failures, Mm-hmm. So, I was sliding the keyboard. I guess I must have hit it. Anyway, I was going to move it anyway. So now we have some digital EGR valves. GM calls theirs a linear EGR valve, which mounts in somewhere along the intake. So it has to have a passage from the exhaust, but they're using an electric stepper motor to move these certain amount, so they can vary how much EGR opening they have a lot better than they could with a vacuum signal. And you'll see some things out there on different engines, the way they've designed some things that are kind of goofy. But one of the common things on the GM digitals was a little piece of carbon getting in there and keeping it from closing back. Okay, so they'd come in running real rough, or they would not at all, depending on how big the chunk of carbon was, right? And so the good thing about that was you could take your scan tool and cycle it all the way open, okay? So the first procedure you do when you have that situation, the other thing too is it monitors its position. So you can hook a scan tool up and it says desired EGR 0%, actual EGR is 42% or whatever that piece of chunk of carbon is keeping it at, right? So you can tell it's not where it's supposed to be. So that's a good, quick, easy thing to see on the scan tool. But you can take the scan tool, if your scan tool is capable of doing bidirectional controls with that particular vehicle, which I've always had the factory tool, so the factory different, the Tech 2 you definitely can. So you basically start the car up and rev it up and take the scan tool and open that panel all the way up and blow the chunk of carbon out of close it back, and usually it blows it out. Sometimes it don't. Sometimes you gotta pull them off and pry it out with a screwdriver.
So
There is an aftermarket gasket that has a little screen in it to keep the carbon from getting to that spot. So the factory gasket does not have the screen.
Make it my understanding. This style,
Uh-huh.
are those, the orifices for the exhaust gas, are those internal in the head?
So, in this diagram, they have that drawn that way, yes.
Okay. In realistic, is it?
And it, yes, some, yes, probably most, of the digital ones, yes, for sure. Okay. Yeah, most of our EGR passages that we have, at least one of the two is part of the intake manifold or the exhaust manifold, depending on where they mount the valve. But most of them will mount the valve on the intake because it's colder, right? They don't have to deal with so much heat. And run a pipe from the exhaust manifold to it. So there's lots of variations there. But like what GM did on their digitals, that was when they called the linear EGR valve setup. It mounts on the front of the intake manifold, but they took that exhaust heat crossover that's in the center of their cylinder heads that they needed back when they had carburetors. It's still there. They never did redesign the heads. That passage is still there. And so, and that, of course, it used that during the throttle body years too. But the cylinder heads still have that passage. Well, what they've done is routed that into the intake and up to where the EGR valve's at. And so now you have those two heat passages, or what we used to use as heat, which was exhaust crossover. That's your exhaust coming in. And then the EGR valve just has to open and allow it to go into the intake. So, yeah, they kind of used their head there and left, because, everything that's port fuel doesn't need that heat crossover passage. And they don't have that crossing over in the manifold anymore like they used to. It's now running up front to where the EGR valve is. And so that was a pretty smart idea for them to keep that. Okay, so here's, and I've been saying digital. The linear EGR valve is a digital EGR valve. It's controlled digitally. It's a stepper motor. But this is a true digital one here. It's got 3 different solenoids, and they're just on-off. Okay. This assembly has 3 different size orifices, so they can turn on 1, they can turn on 2, they can turn on all 3. And they can turn on a combination of number 1 and number 3, or number 2 and number 3, or just each individual one by themselves. So they've got 1, 2, 3, 4, 5, 6, 7, 8, I think 9 combinations of how much EGR flow, just by which combinations they turn on and off. And it's just basically a plunger with a spring, and got a flat disc over a hole. And so that allows the exhaust in and down into the intake. So that's kind of a pretty cool idea. That was kind of GM's first version away from the vacuum diaphragm.
So question real quick, they're showing them like kind of larger and the little appearance cover to be small. So are they exaggerating the lower pieces?
Say that again now.
Like they're showing appearance cover. Is it in is it in a canister or is it in
Yeah,
a little disc?
that appearance cover is just a piece of plastic that sets down on top of it.
So are those actually not quite as large as they're kind of what they have on the screen? I mean, like, I'm not saying that that's life size, but I mean,
That cover does not cover the whole outside of that unit.
Okay.
It just covers up the top.
Okay, that's what I was kind of wondering.
Yeah, it doesn't go all the way over it like a can, but the solenoid mounting plate assembly, it sets down on top of the armature assemblies, because this is the electromagnet, and these are the pieces that move up and down.
Right.
And so this sets down and actually bolts down to that bottom plate. And this is cast iron, by the way, this bottom piece is. And so, I forget now what they use as far as what seals the holes. For some reason, I want to say it was a copper disc. but I really don't remember for sure. I can't remember if this model's got that style on it or not, but it might. So yeah, this sets down on top of that, and that just kind of sets down and covers this
Upper
upper
portion.
end of that,
Okay.
most of them. They may have some that it's completely covered, but I don't really remember. This whole unit is not that big around. You know, it's not really big. Yay tall. So anyway, there again, like I say, they have multiple combinations of the amount they can do by whichever one of those they open. The linear, this is the linear version, and it too is like this big around. This picture makes it look smaller than it is, but it's actually pretty good size. And it has a stepper motor. It says uses a single solenoid. Duty cycle, okay, so they did have, yeah, I forgot, they had some duty cycle controlled ones, but they also had some that were stepper motors, okay? And a stepper motor we can put voltage to, and we can move it in increments, right? We can move it in numbers of degrees, and it's threaded, so as it's rotating, it's picking it up, so we can move it up and down, however far we want. This one being a duty cycle solenoid, they're going to turn it on and off, and so it's sitting there clicking up and down. Okay, I forgot about those. I don't even remember what those were on, but I remember them making noise because they're opening and closing. That spring sitting there slamming it back closed, and it's doing that at a pretty rapid rate. So it's a little bit louder than an injector noise, because injectors make noise doing the same thing. This is a little bit louder than an injector, so I thought it was kind of annoying actually. I can't remember what vehicle it was. I remember that now. But it says it includes a valve position sensor for feedback. That would only apply if it was stuck. Okay, so it can see that it's not actually moving up and down. Now the true linears that are stepper motors, that feedback gives it in percentage. It knows exactly where it's at all the time when it's functioning. So, twin solenoid EGR control. I haven't dealt with this. Must be probably an import thing. Says one solenoid controls application of vacuum to the valve and opens EGR, and one solenoid allows vacuum to be vented from the valve, and then the spring closes the EGR. Imports like solenoids so much that they do stuff like this. Let's use two instead of just one, because we can do this with one, right? Because everybody else does it with one. Let's use two. So notice that one valve is normally closed, the other one's normally open. And so they work in those back and forth to control that vacuum there. Now, on those with one solenoid, I'm trying to think right now, I'm trying to think of what could possibly be an advantage of having two. If that hose is running from the EGR valve up there and then teed off to those two, I can't see any, why not just go through that one solenoid to atmosphere? I'm not sure. To me, it doesn't make sense to have to. But there again. You will notice that over there they've got a plug-in, or they've got terminals hanging out there, but there would be a plug-in there that would be the computers. There's 3 wires there, so it's basically a potentiometer so it knows where it's at. Okay? And so that would be probably a 5-volt reference, a ground, and a return wire plugged in there. Electronic vacuum regulator, EGR control. Okay. One solenoid controls both application of vacuum to the valve and venting of the vacuum once the EGR is commanded off. Can be duty cycle to control valve position. Yeah, well, the ones that use the EVRV really is pulse width modulator, duty cycled. And so, there again, they're just turning it on and off and allowing a certain amount of flow. Some of them have a temperature sensor on them, okay? The first EGR valves that I saw with temperature sensors were on 85 or 6, whenever GM came out with their tune port injection on the Firebirds and Camaros. Those had EGRs, and EGR was under that center section of the intake, so you had to pull the intake into it, the upper intake. Those were a three-piece upper. They had a center section and then two sets of tubes that went down to the lower intake, which was the runners. And they had Torx head bolts coming in from the side and down from the top. And they were kind of a trick. Of course, that was during the time frame when we were having to clean a lot of injectors and replace a lot of injectors that we couldn't clean. And so it paid about 2.5 hours, if I remember correctly, to put injectors in one of those. And I got to where I could do them in about 1.5 hours. But it's a trick, because you can't, since there's 3 pieces there, you can't tighten anything up until you get all the bolts in it. And then you can start tightening up in the proper sequence and all that. But that EGR was down under there, and it had this temperature sensor threaded into the base of the EGR, into the cast iron base of it, with just a little pigtail hanging out that plugged in back there. And so I did have, well, actually the one I had to replace was on a Corvette, but they used that engine in Firebirds, Trans Ams, Camaros, and Corvettes. But that temperature sensor, trying to remember exactly why they had that temperature sensor there. I think they were using that to determine if the passage was actually clear and allowing it to flow exhaust, because it would heat up when that opened, right? So I think, if I remember correctly, that's what they were using that temperature for. It's really all that kind of makes sense. You know, I've had several different strategies over the years of how they're determining if the EGR is actually opening or not. And you know, I know I mentioned a while back on the 87, 88, 89 trucks, especially 88, 89s, that to test the EGR system to see if it actually opened, they did a test while you were cruising down the road, opened the EGR valve and watched the O2 sensor for change, okay? And so we were getting situations where they were coming in with EGR codes because the O2 didn't change enough and the fuel filter was stopped up on the truck. That's why, because the O2 was running leaner than normal and they didn't make enough change. So it didn't see that the EGR was functioning and it set the EGR code. And you could have that EGR code well before it got enough fuel restriction that it caused a lean fuel code in those trucks. So it was very common, you know, it was to the point of, and those were the ones that had an EGR solenoid, so you know, you went in there, plugged your scan tool in it, you walked out there with your vacuum pump, you made sure the EGR valve worked, you popped the hose off, you switched the solenoid with your scan tool, made sure the vacuum switched to it, you lifted up the EGR valve and made sure it killed the car or the truck, that way you knew the passage was open. And at that point you just checked everything related to that EGR system and everything checked fine, right? So then you go pull the fuel filter off of it. Because the first one I had, I don't remember how long it took me to figure that out. You know? But I finally figured it out by reading the code set criteria and thinking about, well, And then driving it and watching the O2, it's like, after a little while, I realized the O2's biased lean. It's like, okay, that's the problem. It's running too lean. She's not lean enough to set a code yet. And pulled the fuel filter off, sure, I stopped it up. And so from then on, it's like, check the fuel filter, you know. Okay, so I mentioned the DPFE. This is a PFE sensor. Now I'm blank on what the F is in. Pressure, I forget now what it stands for. Blank. But you see that sensor is plugged in there to the exhaust manifold, or in this case, this is the way Ford did this. It's actually a metal pipe that comes off the manifold up to the EGR valve. And so it's a piece of pipe about that big around. Notice the metering orifice there. Okay, it's a restriction so that when the pressure drops, when the EGR valve opens, it takes it a little bit of time before that pressure builds back up on that side. So they can see that pressure drop instantly, basically. And so it's just measuring the pressure. And later is when they added the DPFE, which has a port from the sensor on each side of that meter orifice. And it does a better job of checking the pressure difference. That way they know when the EGR is supposed to be on, it actually is flowing. So that's a lot better than looking at O2 voltage, in my opinion. Except their sensors failed a lot. Okay, so there's the DPFE version. Dual pressure feedback EGR is what that stands for. Now I remember. And PFE is pressure feedback EGR. So the difference between the two is the dual has two lines, the single only has one. And there again, like I say, we'll see a lot of those. This is a diagram. See that throttle blade up there? Except they've got their throttle plate. I guess it can be leaning. It doesn't matter which way it's leaning. But anyway, so that port R is right there at the point of where that throttle blade closes. And so it's kind of, the throttle blade is blocking the vacuum from it until you crack it open a little bit. Okay. So off idle is when that would get some vacuum to it. Okay. For E, see that is going to the EGR vacuum modulator. Okay. So we have this modulator here that has two vacuum supplies, one of them intake vacuum, one of them ported vacuum. Okay, so that's going to control the position of that somewhat, depending on the vacuum level and where our throttle's at. Okay, so they can vary that amount there. VSV is a vacuum switching valve. That's what that stands for. In this case, it's electrically operated. If you see it written as TVSV, that's thermal vacuum switching valve, and it will be switched by cooling temperature. So this is monitoring the back pressure to help control how much EGR. It says the transducer bleeds off vacuum when back pressure is too low. Just to keep it from opening when there's not enough back pressure in the exhaust, which is typically at low idle speeds, low load conditions, situations where if you open the EGR, it would create a stumble in the engine or something else. create a clean misfire, basically. Okay, most EGR issues will set a DTC. Some of the older ones, and before computers, definitely won't, but some of the older ones, even with the computer system, can have EGR issues like the spring in it's getting weak and it's opening too soon, causing a hesitation. It'll never set code because it didn't have the electronic capability or the programming to determine that was what was happening. Okay, so I've seen a few of those that the spring got weak in them and they just opened too easy. And usually it takes about 5 inches of mercury before they unseat. But some of those where I've had that situation where I had this hesitation, and you know, you go through the test on the EGR and you do it with your vacuum pump. You know, your hand vacuum pump's got a gauge on it, so you can see how much vacuum you're applying. And so this is how I caught a couple of those. It was just like, man, that thing starts opening like 3 inches of vacuum instead of 5, you know, or 6 or whatever. And usually those were cases where I had something else at the dealership or whatever. I could walk over and pop the hose and stick it on there and say, yeah, this one opens at 6. This is the same EGR on that. This one's open at 3. Okay. Well, that's going to cause a hesitation. And so sometimes you just got to compare, but you got to make sure they're the same one. And but I would venture to say of all the ones that I've tested, they've all been, just going off of memory, and it's been a long time, but they've all been above 5 inches before they unseat. Okay. And so the ones that I had hesitation problems with, they were always below 5 inches before they started unseating. So they were just opening up too soon, creating a hesitation. So then, of course, they talk about, you know, passages being stopped up, stalling of the engine at idle when opening the valve does not necessarily mean the passages are clear enough to control NOx under higher RPM or low. Yeah. So how do you know? Well, the only way to know if an EGR system that will kill the car by opening it up at idle is not flowing enough would be with your exhaust analyzer on a dyno, would be the only way to find that, right? In that case, I would say the customer would never know it, right? Unless they were getting their emissions test done in Utah. And then they would say, well, it don't pass. We can fix that for you. Depending on the car. And they have to pull the intake off to fix it. But, you know, got to clean that passage out. So, that's, in that case, that's the only way you're going to be able to find that. Most of the time, at least in my experience, if it will kill the car when you pick it up, they will never have any spark knock issues because of EGR. It's obviously flowing enough to keep the combustion temperature down enough. Now, that being said, you never know when somebody's going to get a tank of fuel that's real volatile and reignite, regardless of what's in the car. Regardless of everything's working, you know, that's always possible. But it's not going to be a sustained thing. It's going to be, you know, one tank and done. All right, EGR system is responsible for controlling what kind of emissions?
Exhaust gas. Right?
Well, exhaust gas, but what part of it?
Oh.
Bad stuff in the exhaust gas does that control?
Oh, the,
NOx.
NOx,
Yeah.
right, oxides of nitrogen.
sorry, I'm getting tired.
It's okay.
I totally understand. Let me see how many I've got left here.
I don't understand. I drink coffee and then I get tired. That makes
I know.
literally no sense to me.
I drank this thing, and I could probably go take a nap.
It really.
Okay,
Maybe I need more caffeine than what they've been
Maybe
putting in
so.
it.
So catalytic converters. We've had catalytic converters since the late 60s too. Definitely since 1972. There were some issues, of course, with those in the late 60s because we still had leaded fuel. Leaded fuel killed them. And so they learned real quick that, well, okay, we got to get rid of the lead in fuel. But our catalyst does separate different things. The parts of the catalytic converter do separate things. We have an oxidation catalyst and we have a reduction catalyst. Then notice down here at the bottom, this three-way catalyst contains a reduction bed and an oxidation bed. What else does it have?
I was gonna say, because that's still only two.
It's still only two, isn't it? That's not very good, is it? Okay. Three-way catalyst, typically, my experience with those have been injected with air directly into the catalyst. Okay, so there's three ways that they're controlling what's going out the back end of it. Okay, so our oxidation catalyst, this is where we're going to burn stuff. We're going to oxidize it. Remember, adding oxygen creates a burn. Okay, the chemical process of burning is adding oxygen to the hydrogen and adding oxygen to the carbon, and we get water and CO2. That's what we want coming out the tailpipe. Okay. What we don't get combined good comes out as hydrocarbon and CO, carbon monoxide, right? Okay, oxygen is needed. Notice it says may be provided by air system or switching of O2 sensor. Switching of O2 sensor. I don't like that term. Okay. I like the term leaner fuel mixture. Okay? Because a leaner fuel mixture has more air to fuel content, right? Okay. So there are times where some of our systems will lean the fuel mixture down to heat the converter up to get that burn started, but it won't last very long because it's, heats the converter up. You don't want to get it too hot. So they get it up to temperature that way. Reduction is when we split a chemical, okay? And so in this case, they're using rhodium as the catalyst, it says. Up there at the top, it says platinum and palladium. I'm really not sure how the chemical process works, but those materials, the platinum, palladium, and rhodium, are catalysts. And a catalyst is in this case, mineral that will create a chemical reaction when it comes in contact with these other substances without it being used up. In other words, the amount of platinum, palladium, and rhodium in the catalytic converter from day 1 to day 20,000 or whatever, unless it gets too hot, will be the same. Okay, it doesn't go away. Okay. What kills converters is, well, leaded fuel used to because it coated these materials and then they just couldn't function. Okay, it just like put a layer of stuff over the top that then the chemical reaction didn't happen. The other thing is they get hot and melt. Okay, and so nowadays the only thing that kills them is they get hot and melt. Okay. You will find it's very common for someone to bring their vehicle in. I've got this rattle noise under my car, and it's rattling, and it's one of the honeycomb style converters that got hot enough that it melted some. And I've seen some of these that the honeycomb itself just melted enough that the whole big chunk was loose inside the housing. But most of the time it breaks into separate chunks, and it's all rattling around in there. If it gets hot enough and run long enough and all this, it can get to where those melt together and stop up, restrict the exhaust, and the car will run. On the early bead type converters, they had little beads in them, that were coated with this stuff. And they were dual bed, and they had two separate chambers with different stuff in them. Those would get sooted up, coated up, and restrict flow, and eventually kill the car.
In our data, one of the datas, they have you use a hammer to tap on. And
Tap
you
on it to listen.
You can hear
for
it rattle
rattling.
in there,
Yeah.
So that would be what the bead type would sound like?
That would be what the honeycomb type would sound like.
Oh.
Yeah. The bead type, I say that. I don't know that I've ever heard one of the bead types rattling.
Oh.
Okay. Those just had a tendency, and they were different in the fact that the exhaust came in the top. They had two layers. You know, those catalytic converters were the ones that were like this big around. They were kind of round shaped and about this thick.
Mm-hmm.
And they actually had two layers with a piece of metal in between the two. So the upper bed was your oxidation catalyst, where it came in from the exhaust manifolds, went in the top, and it went through those beads down in this, the piece of metal separating the two, and then through baffles and back this direction through the reduction catalyst, and then back again to go out.
Oh, wow.
Okay. Well, these would melt and set down in and plug up the holes between those metal layers, and so they would just stop up. Yeah.
So you wouldn't hear any rattling at all
Yeah,
from it?
yeah.
'Cause it'd
I
be a
don't,
big
I
old
don't
lump?
remember ever hearing a rattling. Well, let me rephrase that. I have heard rattling, and it was the piece of metal inside that was broken loose on one that someone had knocked the plug out of and knocked all the beads out of. And so there was nothing left in there but the piece of metal.
Oh, okay.
And so I've heard that, and I assume that's what the rattling was. But it was one of those that's what people used to do when they get stopped up. They had a plug in the bottom of them that looked like a freeze plug. And so they would take and knock that out and dump the beads out of them. And put a plug back in it and go down the road. It was against the law, but they did it, right? And then the aftermarket companies came out with a test pipe. Okay? So they built these pipes that would bolt in place of the converter. And of course, a lot of those converters were slip fit with clamps, so they're a pain to get on and off. But the test pipe were specific to the vehicle for testing purposes only, right? Yeah, right. People go buy one of those, take the converter off, put the test pipe in. Well, it was an extended test. We're still testing it. They test it till the car quits running, or they sell it or whatever. So that was, I don't know if they still sell those or not. But, that's what people did. So anyway, our reduction catalyst is splitting. We're not splitting atoms, we're splitting molecules, right? Splitting these compounds up. And so we're taking NOx and we're splitting it off into N2, which is nitrogen, and CO2, right? It uses CO as part of the chemical reaction, they say. Well, yeah, because we add oxygen to CO in this case. So it's doing two things there. It's splitting the NOx. Okay, now remember NOx, that X means that could be a 1, 2, 3, 4, whatever. Okay, so it's got nitrogen and some number of oxygen molecules. Okay, so we have to separate the nitrogen from the oxygen and then combine that oxygen with CO that got past the oxidation catalyst that didn't make it to CO2, right? So then we're going to combine that oxygen with the CO that got through the first part and now convert that to CO2 out the tailpipe, right? And now they tell us CO2 is bad, so now the only way we can get rid of CO2 is not burn fuel. Okay, that's it, not burn fuel. So burning less fuel helps that, and going electric stops that, right? And so they're getting, like I say, a three-way catalyst. They're gonna have an air pipe coming from an air injection pump going into the side of the converter. Okay? And so that's adding oxygen into that reduction side. In case there's not enough CO2 there, we can still separate the nitrogen and oxygen. Because oxygen that we breathe is O2, right? Okay, so if we add O2 in there, depending on what our X number is, we can convert some of that. If it's NO1, we can add an oxygen molecule to it and make it oxygen, separate the nitrogen off, and separate the one oxygen molecule, add another one to it, now it's O2, which is good, we breathe O2. So, I don't know who figured it out, they're pretty sharp. This is that same picture we had up that was in this presentation the other day. Kind of shows you how the, what I call honeycomb style substrate is. And it's basically a ceramic coated with platinum, palladium, and rhodium. Okay. And one half of that chunk in there is going to be platinum, palladium, and the other half's rhodium, which are precious metals, right? Which are expensive precious metals, and people will steal them.
The rhodium, rhodium is actually what my ring, they coat it
Oh, yeah?
every so many months.
Oh, yeah?
And they electrically coat it. It's really
Right.
cool.
Electrolysis process.
Yeah.
And I don't know if they do this electrically through electrolysis, which electrolysis is typically done in a liquid form and run electricity through it. So that's probably how they do this. I'm not sure. But yeah, at some point, because they have to get down inside all these passages.
Yeah.
So they probably are taking this front section and putting it in some sort of container with the platinum, palladium, and some solution.
It's kind of interesting because in the little, because it has a little on my setting, they've showed it to me in between what they were doing, and it actually, like you're saying, they dip it in a liquid, and then it solidifies it, but there's still chunks left. You just blow them off in between the little.
Oh, yeah.
So it's kind of interesting. So thinking about that, they probably just, blow out the little chunks, and I just don't know how they would revert it back to a liquid unless they melted it, or I just wondered about that. But
as with everything electrical, remember we have positive and negative, right? So if you take this electrolysis process and run this through as positive to negative current, and it plates it to the surface, if you run it negative to positive, it
liquefies
turns it loose.
Oh wow!
Yes.
I didn't know that.
So that's like some of the gun coatings that they're using, their electroplating stuff. They can take it back off.
Oh.
What's up?
I'm not going to be in here today.
You're already in here today.
Well, I mean,
This
for class.
afternoon?
Yeah.
Okay.
My grandma is at early stages of dementia. She called the cops on me last night, saying that I snuck in through the vents in her floor
Yeah.
and stole a bunch of stuff from her house. So I have to go talk to the police.
Right.
About my bad flexibility of
Right.
through vents and
Right.
whatnot. Like they already know that.
Tell them you're Santa Claus at Christmas.
Yeah. They already know it's not me, but
Right.
they just don't have to.
Yeah. Okay.
So I'll report.
No problem. All right. Well, have a good weekend. If I
Oh,
don't
try.
keep you.
Yeah. I just have to say, getting old sucks.
Oh yeah. Oh yeah. That's the, I guess, the worst part of it when you have that dementia situation. It's like.
Yeah,
how you deal with that. It's like,
I went down to see my grandpa, and he was a little bit kind of being like, he was telling my dad, he's like, I got all these goddamn grandkids and they won't stay off my tractor. And he's like, there's grandkids are pretty much grown now.
Right,
You know what I
right,
mean? And he's like, I can't get him to stay off it. Da-da-da. And he was throwing a fit because he kept thinking, and he's like, I got to get out there and get him off that damn tractor. They won't leave it alone. My dad's like, Dad,
Yeah,
tractor's fine. It's not even here.
that's right, right. My grandpa, he didn't really get any of, didn't really have any of that aggressive stuff like that, you know, or accusing people of doing stuff. He just got where he didn't recognize people
Yeah.
quite often, but you tell him who you were, and then, you know, I think most things you couldn't see very well. But we had his 105th birthday party, and somebody had brought pictures, old pictures, and he had a picture that was him and 3 mules when he was a teenager. And I sat there and listened to him talk about those 3 mules for like 30 minutes. I mean, he remembered everything about those mules and how they would do when he was plowing with them and all this stuff, just like it was yesterday, you know. But then somebody walk up, who are you?
Yeah.
You know,
It's just amazing how much their
who are you related to?
long-term memory is so clear, but their
Right.
short-term's
Right.
not too good.
Yeah. He said, yeah, this mule here, if you work too long, because it's really amazing. 'Cause I read a couple of mule magazines, and I've been wanting to buy a mule, and there's some articles that of all these old timers that used them, you know, because nowadays nobody uses them. There's few people use them to plow with, and none of them use them like they used to, as much as they used to. But they were amazing at some of the things it would do. But anyway, he was saying this mule, and some of the articles I read that at 5 o'clock their mule would stop, and it's like halfway down a road, 5 o'clock the mule would stop, you know, and they could look at their watch and it's 5 o'clock on the dot, you know. They knew what quitting time was. It just blows my mind, you know, how an animal
Yeah.
can know, you know. And it's like all they could do to get them to finish that row out, you know, and then go to the barn, you know. And but he said this one mule, Red, it was the red mule, his name's Red. Red would get mad if you worked him too long. And Red would step on every other corn stalk if he was mad. He said he wouldn't step on every one, he would step on every other one. Just right through it.
I'm gonna show them.
Yeah. He said when Red started stepping on the corn, you might as well quit. You know, give him a break, and you know, either he was just mad because you was working him too hard, of course in Arkansas too hot and all that, and he needed a drink or something. He'd just start stepping on every other corn stalk. So you take him over in the shade and take him to get a drink or whatever, and sit there and wait a while. And,
They
you know,
are.
and then you go back and go at it. He never touch one. You know, it's like-
I know they are stubborn. My dad he always has mules. He usually uses them to haul when he goes up to the canyon to
Yeah.
hunt or whatever, but he likes riding them a lot better than having them haul because they're a lot more sure-footed.
Yeah. Oh yeah.
And he's like, it's similar to different types of suspension vehicles, he said.
Yeah. Oh yeah. Yeah.
He's like, he says they're not as rough riding as if you had like, you know, other, you know, horses or whatever.
Their scapulas in the front move up and down more than a horse does, so they don't have as much of this.
Yeah, the swaying.
Yeah. And
So-
they're just smoother, you know. Okay, testing converters. Rattle test. Yeah. If you're going to hit it with your hand, make sure it's not hot. Okay. Remember, our converters get really hot when they're functioning. Okay. Back pressure test. Back pressure should generally be under 1.25 psi. Okay, when you're doing back pressure tests, there's 2 methods, basically. And one of those is an adapter that you take the oxygen sensor out and thread this adapter in there, and you hook your gauge to it. Okay, and it's basically just a little nipple to put the gauge hose on. I don't like those because if it's very old at all, there's always a possibility of that oxygen sensor pulling the threads out when you take it out.